Okay, so today I'm going to be covering an issue that I probably went over about 3,000 times before in the past, but I'm still getting questions about it. I'm still getting people that want to replace GPUs over this issue, so I'm going to cover this in a more in-depth factor. So tonight we have a 2012 Retina 15-inch with an 820-3332-A board. Now this one comes in with a complaint of no video. So this is a incredibly common issue on this model. So sometimes you'll get no video. So in the case of this one, we have black, nothing, no backlight, nothing on the screen. It's completely dark. There's no image, nothing. The fan is spinning. It chimes, it posts. Everything else is good, just no image. So that is one way this can present. Let's go over how this presents if you do see it in your repair shop. So, loss of video, that's the major one. Sometimes it'll be fine when it's cold. Once it gets hot, you'll start getting black screens. Sometimes if you set the computer down, the screen will go black. Other times it'll just randomly go black. Kernel panics is another common one, very common under load. You'll get kernel panic. Very, very, very rarely video distortion. So if vCore drops down too low real quick, you can sometimes get a little bit of video distortion. It is very rare. And we really don't see that, but that can happen. That's not out of the question. And this issue is a very, very fixable issue. It's a very easy to solve issue, so we're going to go over how we diagnose this issue. So here is our board, here's our laptop. There are a few coils here at the bottom, so there are some inductors at the bottom right near your CPU and GPU here. Let's pull up the board view for this. Okay, here's our board view. So you see these inductors right here? We have a few of them, or two of them. The ones that we need to pay attention to are going to be L8930 and L8960. These are both the vCore inductors for the GPU. So here's our GPU, here's our CPU, and this is going to be our phase side for the MOSFETs. We have a few MOSFETs here that supplies power to the GPU. These are going to switch very rapidly between 12 volts and 1 volt, and it's going to go through the inductor and a few capacitors, and we're going to get 1 volt out of that for our GPU. So, since we have no image, we have chimes. Since we have no image and chime, and especially with the history of this board, it's safe to say we can start checking voltage on these coils. So let's go ahead and check voltage on these vCore coils. So let's grab our multimeter here. Let's switch over back to my other view. Okay, so here's our multimeter. You can see that, hopefully. You can see we have no voltage, obviously, it's not touching anything. Let's measure GPU vCore. Notice we still have 0 volts. We have nothing on that coil. We have nothing on that coil. We have nothing on that coil. And this should be CPU vCore. We should have some voltage there, and we do. Again, right here. No, maybe not. So the CPU, when it's not under load, it's going to be, that's I think 1.8. Yeah, it was no, 0.8. So we have no CPU vCore. So we have no GPU vCore. There's no power going to the GPU, and therefore it cannot work if it doesn't have power. So if you have 0 volts on GPU vCore.
So if we have 0 volts on GPU vCore, you don't reheat the fucking GPU, you stupid noob.
Okay, let's have a look at the system block diagram to see where GPU vCore comes from. So if you look at this page of the schematic, it's power system architecture or system power architecture. You can see voltage in from the AC adapter, goes to the ISL, whatever. That's not very important, but we can see right here something labeled GPU vCore. So we can see this is an ISL 6263-6263C. In short, this is going to be our supply voltage for our GPU. However, there's a little bit more to how this works than just this chip. So let's go over and look at this chip more in depth. So you can see this is a buck converter. So what a buck converter is going to do is it's going to tell these transistors right here to switch. It's going to go through an inductor and a series of capacitors. So how this is going to work is it's going to switch 12 volts to 1 volt, or 12 volts to 0 volts very quickly. After going through the inductor and through some capacitors, it is going to come out a nice 0.9 volts that we want for our GPU. So if we have no volts on vCore, if this is not working, there's several things that could be going on here. Either there is going to be an issue around this chip, so there could be an issue in any of these resistors or capacitors around the chip that's causing it not to work. This chip could be dead, or the most common thing, which is 99% of these, is that the solder joints on this chip are cracked. So I get a lot of questions, or a lot of people saying, Should I reflow the GPU? Should I do anything? No, do not touch the GPU. It is not the GPU. It is related to this circuit. It has nothing to do with the GPU. The GPU cannot do anything. The GPU cannot do what it's supposed to do if it does not have power coming to it. So before you do something stupid, please check if the GPU has power going to it. So this is a very common issue, and this was actually covered under a recall program. So affected models of this year and generation are actually covered by a repair program, which is now taken off the internet. However, all these 2012s were covered by this program that have this issue, and they'll replace your board, and they give you a board that's going to develop the same issue. However, they can slow this down by putting a little piece of rubber over the chip. So how this happens is this board is very flexible, and it flexes in the enclosure. So over time, the shock of setting it down and just doing regular things is going to cause the board to flex, and that chip is right on an area of the board that flexes. So it's right in the right area that it's going to flex and cause the solder joints on that chip to break. So what they did is they put a little piece of rubber on this chip so it mashes the chip against the keyboard. And now this helps it, however, it does not solve the problem. Eventually this will still usually happen, and it's going to still do the same thing and just slows it down a little bit until it's out of warranty and out of range for that repair program. So we're going to inspect this chip under the microscope, and we're going to see if it's infected by this issue. So let's go ahead and take the board out. Okay, our board is out of the enclosure, and we actually have a little bit of a different issue than what I was hoping for. So, you can see right here we have some moisture ingress into the computer. This looks like coffee. As you can see here, it's on the heatsink, and we also have some right by our lovely VRAM chips. So these are our video memory chips, and if our video memory chips are not working, then it's not going to work at all. However, this is not going to cause us to have 0 volts on VCore. This can cause no video, but it's not going to cause us to have 0 volts on VCore. What is going to cause us to have 0 volts on VCore is going to be this guy right here. So let's have a look at these solder joints, and we can see several are cracked. So most likely, we have nothing that, even though that VRAM chip has a bunch of junk under it, that most likely is not our issue. So if we can look here, I'm going to show you guys what to look for. So this may be a little bit hard to see. Let me turn my microscope. So if I turn my microscope so it's at an angle, I bet you guys can see it a lot better. So let's have a look. Perfect. Move this here and adjust the focus a bit if I can. Alright, so that's at max zoom. So see this right here? So you can tell that, see that little chip there? That's actually a crack in the solder joint. That's present on here, here. And if we look close enough, the chip is actually not touching that. There's a break right there. So you can see right here, there's a few of them. That one's a little bit affected too. I'm sure it's going to be affected up here too. It's usually common on that top side as well as the bottom side. This is how it's supposed to look. See how that looks normal? And you can see there's a definite difference on the other side. A little bit of junk or coffee there, but that's not too bad. That may cause our issue too, but I doubt it. What our issue is going to be these breaks in the solder joints right here. So it's very apparent this is what's causing our issue. So how we're going to fix this, we're not going to go reflowing the GPU or replacing the GPU or reballing it, because that's stupid. What we're going to do is put a little flux around this chip, and we're going to add some fresh leaded solder to the pins of this chip, and then it's going to be good as new. So let's grab our flux. Since this is liquid damage, obviously it's going to go in the ultrasonic, so I don't really have to be concerned about how much I use. So the more the better. The more that you put, you're probably going to get a better joint. So let's go ahead and turn our iron on. Can't talk. Turn our fume extractor on. Iron is just about hot. There we go, fully hot. And we're going to feed some leaded solder into this chip, right in this area. Those are nice. Nice resoldered pins. Another thing I've seen people do this is I've seen people completely destroy these boards with Radio Shack irons. Okay, if you have a Radio Shack iron or anything like that, don't even attempt to do this. You need a good iron, so preferably Hakko or whatever you can get that has a small tip like this. And please know how to solder QFN chips before you attempt this. You know, practice on a donor board, whatever, not on your first customer's board, just so you get a feel of how to do it. Once you do it successfully on someone else's board, then you can do it on your own, or on your customer's board, I should say. And make sure it's actually touching. So sometimes, also, if you bridge this very, very bad, you'll probably kill your GPU because the FETs are going to fail and send 12 volts to it. So make sure you have no bridges, or else you just might end up with a dead GPU. So that should be good. All the pins are soldered. Now, I'm going to put this in the enclosure, so most of the time this is going to fix it. However, we have coffee under a VRAM chip, so it's probably not going to be happy. So what I'm going to do is actually reflow that before, just in case. I don't want to cause any more damage to it. So now this is you may hear me talking about reflowing. This is a completely different case. Now, reflowing is okay if you have corrosion or junk under something. That is perfectly fine. That is not a temporary solution. When you have something that looks like this, that has corrosion and junk under it, then that's perfectly fine to heat that up to get the junk out. So what we would do is use some flux, feed the flux under it. The flux is going to dissolve all the junk under it, and if we do a complete reflow on it, then it'll restore any broken solder joints that may be corroded or anything like that. So I'm going to heat this from far away just to loosen the edge bonding a little bit. I don't want to heat it up too much because then the edge bonding is going to get brittle, and I don't want that. So you don't want to leave any edge bonding under it. If you don't remove it completely, if you reflow the chip completely, then you could have some serious issues. So make sure the edge bonding is completely gone. And if I can't get it, I won't reflow it completely either. But I think I'm fine. A little more heat in there. Because then you'd have to reball it, and that's much more difficult. A little piece still under there. It's okay though. A lot of times you don't have to. I kind of don't like to heat these up fully because you risk killing them. So it may honestly be better just to heat from far away and not completely reflow it. Just get some flux under there to clear all the junk out from under it, and this edge bonding is being a real pain, so that is definitely what I'm going to do instead of a complete reflow. Because I don't really want to reball one of these. That would not be fun. That would probably make me cry. Had someone that took every piece of edge bonding off of their board, so off of the CPU, off the GPU, everything, and I just no, not dealing with that, sent it back. Because what are you doing if you're taking off the edge bonding on everything? It probably means you're heating everything up. And sorry, I know as many people don't want to hear this, an oven is not a solution. So if you're using a repair shop at your oven to try and fix boards, and guess what? You're not really a repair shop. But I am so sick of hearing that on this board. Oh, it's the video chip. It's the video chip. No, leave the GPU alone. It's not the GPU. course, my luck, I'm going to do this video and it's actually going to be the GPU because that's how it works. A lot of times this edge bonding, especially if it's old and has been hot for a long time, so if it's been under load from the heat from the GPU, it's going to be a real pain to take off, as you can see. I don't want to break anything under it either, so yeah, we're just going to roll with that. We're not going to heat this up enough to cause the solder to melt under it. We're just going to heat it up enough to get that flux under there and to wash away all the junk that's under it. I'm going to put some around here too, and then it's going to go in the ultrasonic, of course. So what we're going to do, we're going to lower our temperature to make sure we don't melt the solder. We're going to lower it to like 300. That's enough to activate the flux, but not enough to reflow the solder joints under it. So I just want a nice amount of flux to go under these. That. Sometimes we may have to reflow completely, but I don't want to. I just want to get enough under there that it's going to heat up and destroy the corrosion under it. I don't actually think a lot got under there, so I think we're good. That should be good. Now we're going to let it cool down, and then we're going to test in a minute. Alright, let's put this board back in now that it's cooled down. It won't burn up as soon as we turn it on. That wouldn't be fun. I don't want to deal with a burned VRAM chip. It doesn't have to go in all the way, just enough for some, you can plug in the screen. That's all we really need. Now, the moment of truth, if this works, or if it doesn't work. So let's plug it in, and we're also going to grab our meter here because we're going to measure CPU or GPU V-core. So put this right here, move the scope out of the way, turn it on to DC volts, let's plug it in, fan spin, and is that, wait for it. Alright, we got a pulse. Can't see what that says. If that says 0.5, still no V-core. So, if we still don't have GPU V-core, let me make sure, let's check. No, we have GPU V-core. I just can't see it because I'm looking at the screen and not at the video. And we have GPU V-core. So, and we also have something very special on the screen, which is a flashing question mark folder. See that? Which means this is fixed. So, this is a typical U8900 issue. The VRAM issue, I don't think that had anything to do with it, but it did have coffee on the VRAM chip. It's probably not going to like that. Over time, it's going to corrode. So, let's go over this again. I've done this so many times I can't even count. I've done videos on this, however, I still get people that think it's a GPU. I get people all the time, do you fix NVIDIA graphics card issue? I was told it's the video card, and I tell them, no, it's not the video card. And some repair shops will even argue, no, it's the video chip, it's the video chip. I know it's a video chip. And then what happens is they'll think that they're right, and they'll go get a Wagner heat gun from Home Depot, and they'll burn the GPU, and then they're going to send it to me, and the GPU is going to be all popcorn and brown, and I'm going to send it back because they did something stupid. So, do not do that, please. It is not the GPU. These GT650Ms, whatever these are, almost never fail. It is almost always the cracked joints on U8900. Sometimes you'll get traces around them that'll crack. It happens. Rarely the chip is dead. I've seen it a couple times though, but most often it's just those solder joints that break. So please stop killing these. Please stop heat gunning these graphics chips. I've had people that have had some place replace their GPU with a piece of junk one, and same thing. It'll work for a day, and then it starts doing the black screen thing because it's the joints on U8900. So, please, I'm gonna make this video very clear on my channel that this is what causes it. It is not the GPU. It is almost never the GPU. It is just U8900. So, hopefully, if you have one of these machines that's doing this, you now know how to fix it. If you don't want to fix it yourself, you could send it to me and I could fix it for you. Either fixyourmacbook.com, I think that's mine, that might be Lewis's. We have two similar websites, or www.tcrscircuit.repair. Links also in the description if you want us to fix it for you. And if you have one of these machines, at least now, if you're not a repair shop, you know what's going on with it. So that's it for thank you for watching, and I hope this video helps you solve your problem.